Oh, hi. Now, check out this teacher up here. Sometimes that teacher is like me. You need to follow the rules so that your output will be what you desired. Now, guys, same thing with math. We always have inputs, and at the end, we want to get the correct output. Okay? So, learn function notations today. All right, just like a function machine that we learned in the past, there is always an input, right? That will result to an output. Okay, sometimes we call it the X will result to a Y. Look at all these blue words, they're the same. And now, sometimes the X is the independent value. It's any number that you could think of, right? But it will result into something. Okay, and that's going to be the dependent value. And then now, this is the new one. We have a new vocab for today. We will call that X, that input, the domain. Domain. Remember that? And the result will now be called the range. Okay, what else is new? So we already know that the domain is the X, but we have a new symbol, mathematical symbol. It's f of x. How do you say that? You say it function of x. So you could say f of x. That means function of x. Okay. So remember that. That's our vocab. They all mean the same. These words all mean the same. And these words all mean the same. Okay. So now, if I have an input, an x, a domain of 3, the range will be a 9. What could be the pattern? Oh, it could be plus 6. No, check again because 7 plus 6 is not 17. Oh, plus 10. No, but they have to be the same. So how about this? So if I do this plus 10, is it 43? No. So think of another rule. Now, let's say the rule is a two-step. Okay, think first, think first. So let me give you the step. The rule is whatever to get the y, this is what we did. To get the y, we multiply the x by 2, then we added 3. Does it make sense? 3 times 2, 3 times 2 plus 3 is a 9. 7 times 2, 14 plus 3 is a 17. 20 times 2 is a 40 plus 3 is a 43. So it works. So that is the rule. Okay, now in the word function notation, we will have a new notation now. Y is now called the function of x, meaning the output of x, the result when I know the value of x is fx equals 2x plus 3. So again, how do you read that? The function of x is 2x plus 3. Don't be scared with fx. That means the y, the output, the range, the results. Okay, just based on this table, our domain, you put it in the braces, are 3, 7, and 20. Okay, and based on this table, our ranges are the y values, 9, 17, and 43. So those are the domain and the range. Next. Now, the domain and the range can also be seen in a graph. Look at this, graph 1 and graph number 2. Now, let's start with the domain. The domain could start there. All of this would have x's, right? What are those x values? Oh my gosh, you could name them here. Those are the x values, right? Okay, so are there a lot? There could be an arrow here and an arrow there. So you could say the domain could be what? All real numbers. That means the whole number, the fraction, the decimal, positive or negative. Okay? Now, how about the range? The range, let me change my pen. The y values, look at this point, we'll have this value, that value, that value, that value, that value. But there's an arrow, the line could also extend, right? So what can I say? What are the y values? The y values are all real numbers. Okay, I cannot list all of them. Now, look at the second example, the domain. The excess varies from the negatives up to the positives. So again, the domain are all real numbers. But look at the range. What does the range touch? This point will touch just this point, just that point. All the y's will be the same. All the y's will be here. What's between 2 and 4? The range will only be 3. That's the only range we have. Okay? Next. So today we're going to use a notation to describe a scenario. Dustin makes bracelets to sell at art fairs. He spends $20 on supplies, money that goes out of his pocket. But he sells each bracelet for $2.50, so he earns this money. Use function notation to write an equation that represents his profit, okay, the final money that he earned. What is Dustin's profit if he sells 15 bracelets? So remember, the let's see this one. Each bracelet, let's name this the X, the price of one bracelet. Okay, so let's write this down. So we want to know the profit. Okay, profit is always like this. Profit is always the result of what? Whatever you earn, subtract the expenses. At this point, we don't know yet how much he earned. So, but what we know is that his earning depends on the number of bracelets. So we don't know the number of bracelets, but each bracelet is what? $2.50 times X. We don't know, right? But remember, he spent how much at the beginning? $20. Okay? So the profit will be dependent on the number of bracelets. So the profit will now be my f of x, meaning you could say that's the y, all right? That's the output. So that is your function notation. Now let's write down the profit for 15. The function of 15, meaning the output when I sell 15 bracelets would be what? 250 times 15, then take away the $20. So 250 times 15 is equal to 37.50. $37.50, but take away the supplies, the $20 minus $20, you'll get 17.50. 17.50, right in dollars, that's the profit for selling 15 bracelets. Okay, so we learned about function notations. Don't be scared about function notations. That F means the word function, F of X. And that X means the input or the domain. Okay? And the result will be all of this. How would I know the result? Just follow the expression on the right. That output is the range. Okay? We've given you two examples. If the input is 2, that's the 2 here. All right? Plug it in. The 2 goes inside. 3 times 2 will be 6. 6 plus 1 is 7. That's why we put 7 over there. Input, output, domain, range. Okay, now, if the input, the x, the domain is -4, plug it in there. We base it on here, right? The x will be there. 3 times -4 is a -12. -12 plus 1 is -11. So that's why we wrote the output of -11 there. Now, knowing the function notation or the function rule can help us predict the other output or the other results. So let's solve it over here so that it will still follow the rule. I told you a while ago, if you follow the rule, your outputs will be correct. Okay, your desired output will be satisfied. So 3 times -5, which is -15, plus 1. -15 plus 1 is -14. All right? So we will write it down, -14. Now, let's substitute now the value of 10. 3 times 10 would be 30. 30 plus 1 is 31. So we substitute the value and then the output will be 31. Okay? So if you're asked what are the domains, these are the domains. Okay? And what are the range? These are the range. So what have you observed? The domain could be positive or negative numbers, all right? And also the range could be all the positive numbers or the negative numbers. It varies. Now let's try some ingenuity problem. This should be easier for you. What a function is defined by f of x, 3x plus 1. What is the function of 10? Meaning what would be the result of 10? What will be the output if the input is 10? So simply plug it in. So write down is equal to 3 times 10 plus 1. That's going to be 30 plus 1, 31. So that's the answer. Next, Harold wrote his equation to model the level of water in a pool over time. So there's a swimming pool, let's say, and the water level is at a certain height. Okay, the variable x represents the time in hours. Now check this out, it already has water inside, so the water is already there. 3,500, there is water already. Okay, and subtract, meaning water is going down, okay, water is spilling. By how much? 225 times the number of hours. Okay, which statements is about this equation are true? Check all that apply. The water is rising. No, the minus thing means it's going down. The water level is falling. Yes, falling because water is being displaced. An initial level of the water of the pool is 3,500 units. Yes, that's the starting unit. See that? Okay, the initial level of the water in the pool was 225. No, that will be multiplied by x. No, that can't be you. The pool was empty after 14 hours. No, there's already water inside. Remember the 3,500? Not you. The water level was 2,600 at the height of 4 hours. Are we sure? Let's plug it in then. So f of x, which is my input will now be 4 hours, is equal to 3,500 minus 225 times 4 hours. So 3,500 minus 225 times 4 is 900. Okay, units. So 3,500, the water, minus this amount of water is 2,600. This is now my output after 4 hours. So it makes sense. So this is the answer. Now, third question. A function models the relation between the hours work and the amount of money earned. So this is the money you earn, depends on the hours of working. Okay, which could be the elements of the domain of the function? What could be the possible x that you work? Okay, how many hours could a person work? 5 hours? Yeah, makes sense. Can you work for 200 hours? Yes. 25.5, can you work for half an hour? Oh yes, you'll still be paid. They will still compute for the pay. What is 14 divided by 3? 14 divided by 3 is 4.6, 4.7 hours. 4.7 hours. If you work for 4.7 hours, will you still get money, be paid? Yes. If you work for this, will you get be paid? Yes. All right. But is it possible to work for negative hours? Not possible. You cannot work for negative hours. So your input could be, your domain could be the number 0 going up to infinity. But we don't know, right? You can't work for infinite number of hours. So those are my what? My choices for the domain. it will result with a range, but you're not asked about the range. Okay, last problem. F of x, what is the function of x if 6x plus 1.5 if the f of x is 2.5? So instead of writing x, I write f 2.5. Okay, so 6 times 2.5 plus 1.5. You're not doing anything here. You're just copying it down. F 2.5. Okay, 2.5 times 6 is 15. 15 plus 1.5 is equal to, so the function of 2.5 will result to 16 point, just add them up, 5. So our answer is 16.5. All right, so that's it. So remember, class, results is equal to action plus motivation. Good luck.